Hello everyone, welcome to this Coffee Chat AI podcast. Today, let's see what interesting topic we are going to learn on AI. Hi, what
Yeah.
are you going to teach us today?
Hi. Yeah. We are just digging deep on what transformer architecture is, right? So, since we finished off with decoder last in our last session, so I would like to extend that. So there are few more nuances we may need to uh, cover here, right? So let's see. So we all know once a transformer is trained, there is a additional process or additional post processing which is being applied in order to generate a text, right? So let's dig deep on what that process is, right? So this process is not part of the training your transformer. So this is not done during the training. This is especially done only during the inference, right? So let's see that. Are you interested?
Definitely. So, during the training, we saw it has the encoder, decoder, all of those. So, yeah, let's figure out how it happens during inference.
Sure. So once you have a trained transformer, right? Now it's time to, it's like you can imagine that has a query engine, right? Which is already trained. Now you need to pull the tokens out of it, right? So that token should make sense. There are multiple ways to pull the tokens from transformers, right? First, starting from first, uh, simple decoding strategy is to select the token which has maximum probability, right? I think you would have used this in even in a sentiment classification task, right? Or any multi-class use cases. Whichever tokens has higher probability, you just select that, right? So this is nothing but a greedy decoding strategy. Okay, this is one of the strategy.
All right.
So just like this, we have multiple other ways to extract tokens from the transformer. Okay, so the second one is beam search. Again, most people from the NLP background would have used this, right? Instead of just greedily selecting a token which has maximum probability, beam will give you can create multiple channels, right? One channel will have beam is nothing but a hyperparameter. So if the user selects two beam, right, then you have the decoder creating two different tokens, or it tries to create two different sentences, and the entire probability of the sentence will be taken into account, right? Not just the next likely token. So this is somewhat better than greedy search decoding. I would say this you have to imagine what strategy to pick based on the task here. So if your task is just simple sentiment classification, just a max probability will do, right? What do you think?
Definitely.
What if you are going to generate a sentence, just like a automatic speech recognition or a machine translation, you need to generate multiple tokens out of it, right? So at that time greedy won't make sense at all. So it makes sense, but it won't give you the best output. So people try a beam search in that use case.
I got it. Could you relate with an analogy? Maybe if someone is very new to AI, right? If they're not sure what is a token is, what is this greedy beam search? Could you explain with an analogy to us, please?
Sure. See, it all depends on the task which you are doing, right? So how intelligent the task is. So you could relate this to, let's say you are interacting with a 1 year old, right? So there are few things he or she can try to understand, but they may not say it to you, right? If it is a simple task, if you ask them what is this, right? You know the piece. There is an image with you, image of apple with you, and you can ask them. They can say it is an apple, right? So
Yeah.
or if you ask them to say something like a yes or no, they will most likely to answer it for an 1 year old, right? So this is somewhat easier task for them. But if you ask them to speak a word, generating is actually a difficult task
Right.
than classifying.
Yeah.
So whenever you come across a use case where you want to classify something, so just greedily in the sense, out of all the tokens you have in the vocabulary, just select the maximum token. That's a simple task to do, right?
Yeah.
So this is a simpler task, just like you asking a 1 year old to select yes or no for an answer. So they're likely to select. But what if you ask them to talk a word? right? If you ask them what their name is or what they are doing, so this is somewhat difficult task compared to them answering yes or no. What do you think?
Yeah.
So,
So this generating a word, which category does it like, to the greedy search or the beam search?
greedy is applicable to any strategy. So, any use case you have, you can apply greedy over there.
Yeah.
But the outcome won't be as good as. See, greedy is nothing but you selecting a token. You
Yeah.
first hope you all know what vocabulary is.
Yes, right.
So this we discussed in the last class, right?
Yeah.
So what is a vocabulary?
So in vocabulary, like whatever words we know, we are storing all those in the vocabulary, right? So greedy search is something like the maximum most probable word you would be choosing.
Out of the vocabulary.
Right, I
Yeah.
got it.
Yeah.
So then what is this beam search?
Okay. So let's say you want to generate a sentence.
Yeah.
Right? So using the greedy search itself, you generate two different sentences with let's say with the top sentence, with the whatever tokens get the top maximum probability, you select one, and with the next sentence, whatever has the next high probability, you select one. Okay. So out of this, so once you have, let's say you have a sentence with 5 words.
Yeah.
Okay, and all of the probability of all the words is, let's say, you have to basically multiply the probability of each token to get the probability of the sentence, right? So the entire probability you have now between the both the sentence, whatever sentence has the maximum probability, you select that. So that is beam search.
Oh, wow.
Instead of greedily just considering
Okay.
token by token, that can lead you to local minima most of the times, right?
Got it. So yeah, I'm enlightened now. So in greedy search, tell me if I got it right. In greedy search, you will be focusing only on the next word. So if the next word would be the most probable word. But in beam search, we have various
You
options
give an opportunity basically.
where we are creating the sentence itself. Whichever sentence has the summation of the highest
Not
probability.
summation, product of the probability.
Okay, product of
All
all
the
the words in the probability.
Correct.
If it has the highest, it would be chosen.
Correct.
For example, if I'm choosing like maybe I love dash is the example now, and using greedy search, it would be like I love you or I love apples. Maybe I love you, the word you might have the highest probability and it might be chosen. But when we are coming to beam search, it would be like I love many things. I love beautiful world. I love cute kids. So we will take 3 different sentence option itself and choose
Correct.
which has the most probable probability.
Yeah, if your number of beams parameter is 3, exactly this is what happens.
Awesome, yeah. Like usually this greedy search and beam search, they are little confusing, right? And I hope we got a very clear picture on this.
Yeah,
now.
and this is not left. So I have 2 more strategies or 3 more strategies to add here as well, right?
Yeah.
So next comes sampling, right? Sampling. See, as humans, when we create or when we, let's say we write an essay, right? It's not that we usually write the likely tokens. So beam search basically leads to repetitive tokens. Okay, not often, but at times. So it is better than greedy, but it still needs an improvement. Still, the decoding strategies needs an improvement. That's why we have sampling decoder or top key, top P. So we'll see what these are. Okay. So human text, naturally, when you observe the text written in a newspaper or any blogs, it combines a randomness to it, right? Randomness in the sense it could be, if you want your text to be creative, you need to employ some randomness in that. So that's why instead of so in beam search, as we saw, we are basically selecting a max token, right? Max, whatever token has the max probability, so we are selecting that. So instead of this, what if we randomly select a token from the decoder, right? So this won't be useful every time, but this is a one good direction. That's what sampling decoding strategy is. Then comes top K. Top K is nothing but it's a combination of sampling and greedy. Okay, so in top k you are just asking the decoder to select a random token among the top k samples, top k tokens. Let's say your k value is 5, so you just sort your based on the probability of all the tokens in your vocabulary, you get the top 5 tokens. Out of this top 5 you are free to select any based on it's randomly, you can select any of the token. So this adds some creativity to your decoding strategy, right? So when you write an essay, we hope you all know the GPT-2's story, right? It came up with a unicorn story. So if you want to write a creative story like that, you need something like a top K, right? Or a sampling strategy in your decoder. So this is top K. I hope I'm not boring.
No, no, I hope I got it right. Can I reiterate what you said?
Yeah, just top K is fine. So if you understand top K, then let's move on. Let's see what you understand on top K.
Sure. For example, let's come back to the same example sentence of I love dash,
Hmm.
right? So here, instead of seeing the most probable word or the other things,
Hmm.
we are taking, maybe if top K is 5, we are taking the top 5 most probable words.
Correct.
I love you, I love apples, I love dance, I love music,
Hmm.
I love everything. So among this top 5, like how we do a random sampling in probability theory, we take some random sample and it could be any of among these 5.
Correct, correct. That's
Awesome.
it.
There is also one terminology like top P, right?
Yes, yes.
Are we going to discuss about
Yeah,
that?
that's the last one. So in
Okay.
top P it's almost similar like top K, but when you know the word P here is nothing but a probability,
Yeah.
right?
Yeah.
Do you have something in mind based on this? I just hinted you something.
What I'm guessing is instead of the top 5, whichever gives summation as 1, we would be choosing words still there.
No, you are
No.
over engineering. So it's more
Okay.
simpler than that. So P is nothing but a again. So in the earlier case, right? In top K is nothing but a parameter which the user has to supply. So here P is nothing but a parameter. It should be in the range of 0 to 1. So if you set the probability P value as 0.8, it means whatever tokens you have, right? Their probability should be greater than 0.8.
Okay.
So now you got a list, a handful of tokens whose probability is greater than 0.8, and you can select anyone among that.
Awesome. Okay.
Okay, so that's it. So that's what I know about decoding strategies, and this is something I would say maybe we should focus more on research here, right? Maybe this is still open. And maybe we can try our own creative ways to decode if it's possible. Then this could be a big hit as well, right? So still, I would say that a decoder is a genie, right? So still the best things are not yet came out of it. Maybe a good decoding strategy can come get the best out of it.
So, in less than 12 minutes, I got great insights about the decoding strategies. I'm excited to learn about the future topics. Stay tuned for more such interesting podcast. See what. Thank you so much.
Thank you.